we're going to add 3 more trig ratios. It's exciting. What's the unit circle equation again? X squared plus y squared equals 1. And x sine theta is equal to, and maybe I'll draw this so you can see this better. Here's my unit circle. Here's my reference triangle. This is my x. This is my y. This is my radius is 1. Yes? Remember, sine theta is opposite over hypotenuse. Back in grade 10, you learned that. When we expand to trig in pre-cal, we refer to it as y over r instead. And because our r is 1, sine theta is just equal to our y. Cos theta is adjacent over hypotenuse. So if I look at my reference triangle, it would be x over r. But because my radius is 1, it would be equal to my x. And tan theta would be y. Sorry, I'll write it out as opposite over adjacent, or y over x. So that would be the same thing as, what's y? Sine theta over cosine theta. So from this day on, you need to know that identity. So P of theta is on the unit circle to indicate a terminal point. P of theta is also defined by the ordered pair xy, which now is cos theta sine theta. Oh, there I had my unit circle. Why didn't I see that? Okay, I'll redraw it. X, Y, R equals 1 theta. Okay. So, I don't know why I'm recalling sine theta again, but here we're introducing the next 3 trig ratios. And so, if sine theta is equal to y over r, then cosecant theta is equal to r divided by y. So I write it out as cosecant. So it's the reciprocal of sine. Cos theta is again x over r. So secant, the reciprocal of cos, would be r over x. Yes? And because they're reciprocals, you could say that this is 1 over sine theta. And this would be 1 over cos theta. And what do you think cot stands for? Cotangent. Cotangent, again, was y divided by x. So tan was y divided by x. So cotangent is x divided by y, or 1 over tan theta. But that looks like a negative, so I'm going to fix that up. But more than using 1 over tan, most of the time we use it as, you know how tan theta was sine theta divided by cosine theta? We use more of an identity for cotangent to be cos theta divided by sine theta. All right? So you notice that that's not on your calculator. But the reciprocal function is on your calculator. You have a 1 over x button, or you have an x to the minus 1 button. That's your reciprocal function. Maybe locate it right now. Okay, so let's do some questions based on this. So if cotangent is 12 over 5 and sine theta is greater than 0, find the other 5 circular functions. So the first step is, what quadrant am I in? I hear 2. And why would it be quadrant 2? It's correct. 2 is correct. Why is it 2? Because sine is positive and If they give you information on cotangent being negative, what else are they giving you? Huh? Yeah, but cotangent is the reciprocal of tan. When I flip fractions, do I change signs? No, so because cotangent's negative, tan is negative as well, right? So that's essentially what they're telling you is tan is negative, sine is positive. That only happens in the second quadrant. Okay, so now we're going to draw our reference triangle in the second quadrant. Yes? So if they give you that cotangent is negative 12 over 5, what are they giving you? They're giving you the x and the y. So what's the x? 12, and the y is 5. This is one of those Pythagorean triples. 13, thank you. And if you didn't know, you have to use Pythagorean theorem to... So remember that sine is the only thing that's going to be positive. And now because we know the 6 trig ratios, what else is going to be positive? Cosecant is going to be positive. So you remember your CAST rule, or your all students take calculus, which I prefer. Sine and its reciprocal cosecant. It's hard when you use a thicker marker. Cosecant is also going to be positive. I would not try to add extra acronyms to the all students take calculus. Just, you got to memorize. Actually, I should have talked about that. How are we going to memorize that sine reciprocal goes with cosecant, cosine goes with secant, and tan goes with cotangent? I think tan and cotangent are pretty self-explanatory. So how can we come up with a way to remember which reciprocal function goes with which one? Anybody? We could make a song. A lot of people say two things. A C goes with an S in each case, right? Or a co goes with a non-co. Like this is a cosine, goes with a non-co word. Something like that. Somehow you got to memorize which one goes with what. So, okay. So going back to example 1 here. Now that I have my 3 sides of my triangle, my sine theta is y divided by r. So y divided by r. So that is 5 over 13. And is it positive or negative? Positive. So now I'm going to go to the reciprocal function cosecant. If sine theta is 5 over 13, cosecant is going to be 13 over 5. And it's also going to be positive. So let's look at cosine theta. It's x divided by r. So that would be 12 divided by 13. And is that negative or positive? That would be negative. It looks like an extra line, so I'll just rewrite it. Negative 12 over 13. And then my reciprocal function is secant. So what would that be? Negative 13 over 12. Does everybody understand the negative with the trig ratio? It doesn't matter where you put the negative. You could put the negative on top, beside, bottom, as long as you have one negative. It's all good. Okay, tan theta is y over x, so that would be 5 over 12. And is it negative or positive? Negative, so cotangent would then be, oh, they give you that one, negative 12 over 5. Well, hey, I did it right then, because that's what it turned out to be. Okay, moving on. The point negative 3, 5 and negative 4, 5 lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. Draw a diagram to model the situation and find the ratios for the 6 trig functions. So did you know that we already know 4 of them by just looking at this? What do we know? Why 4 now? Yeah. Yeah, the reciprocal. So what do we know? What's negative 3/5? Yeah, cos theta would be negative 3/5. So that means, what's the reciprocal of cos theta? Huh? Yeah, but what is it called? Secant theta, yeah. Secant theta would be negative 5/3. And what are they giving you when they gave you negative 4/5? Sine theta. So then what would they give you for the reciprocal? That would be cosecant, and that would be negative 5/4. Now, technically you don't have to draw the triangle to figure out tan, because tan is just sine divided by cosine, right? But it does say to draw a diagram to model this situation. Which quadrant should I be drawing this in? The third. Okay. So here's my unit circle, and there's my reference triangle. And this point is what they're giving you is negative 3/5, comma, negative 4/5. So technically you could say, well, that means they're giving you this little reference triangle. They could be, yeah. Does everybody see that when you have two triangles like that, those are similar triangles? So this is really a big 3, 4, 5 triangle. Yes? Yeah. Okay, so I don't know if drawing the 3, 4, 5 triangle adds to anything, but we do know that this is 3/5 and this is 4/5. So what is my hypotenuse going to be? Well, it has to be 1 in the unit circle, so I don't even have to solve that. But anyways, what is my tan going to be? Tan theta would be negative 4/5 divided by negative 3/5. So we can flip and cancel. Does everybody see that the 5s will cancel and I flip and cancel? And I'm left with 4/3 positive. And that makes sense. Tan should be positive in that quadrant, which means cotangent then is 3/4. Any questions there? Okay. Sine theta is 5/13, and theta is between pi/2 and pi. What are they giving you when they're saying this? Yeah, it's between, so pi/2 is here and pi is here, so that means my reference triangle has to be drawn in here. And they're giving you that the opposite is 5 and the hypotenuse is 13. Oh, this is a famous Pythagorean triple again. What's the leftover side? 12. Do you see what I'm saying? If you know those, it just makes things a lot faster. Okay, so if sine theta is 5/13, we know that cosecant theta is 13/5. What's cos theta equal to? What's cos theta equal to? Yeah, 12/13. Is it negative or positive? Negative, and the reciprocal of cos is secant theta, and that would be reciprocal, so that would be negative 13/12, yeah? Next one, tan theta, what's that equal to? 5/12, positive or negative 5/12? Negative in that quadrant, and so that means cotangent would be negative 12/5. Pretty easy, hey? All right. What are the coordinates of P of theta on the unit circle if it also lies on the line from the origin to the point 4,3? So this is 4,3, which means I am drawing a reference triangle way out there. And that means this is 4, and this is 3. So what is this going to become? 5. Now, I guess things to note, and maybe you didn't realize this, that this small triangle right here, that when you find cos, and sine, that this point on the unit circle ends up being cos and sine of the big triangle. So just watch here. So what would my sine theta be equal to? Well, it would be 3/5. Which means that this right here is 3/5 if this is 1, right? And just to go further, see, this is how I cos theta would be 4/5, which means this x right here is 4/5. Now, you could have actually, in order to do this, just to show you, and you wouldn't do this in grade 12 pre-cal, but I'm just saying grade 9 kids could figure this out, because this is what's called a similar triangle. And somewhere you learned that if this is 4, and this is 3, and this is 5, and this is 1, we can actually figure out x and y. Because it's all proportional, right? So 1/5 equals x over 4. Do you see? And then you just do a cross multiply, so you get x is 4/5. Do you see that? Same with this. 1/5 equals y over 3, and you can get that y is 3/5. So this is not magic here. You've known this since grade 9, or maybe earlier, but maybe you didn't realize that when you have similar triangles, the trig ratios are the same. Because this angle right here is the same angle. So does it make sense to you that cos of the same angle would be the same thing, right? So it doesn't matter if it's the big triangle gives you 3/5 or the small triangle gives you 3/5, sine is 3/5. Okay, anyways, going back to this would be cosecant theta would be then 5/3. Secant theta would be 5/4. Everything's positive in this quadrant, right? Tan theta would be what? 3/4. So cotangent theta would be 4/3. Okay, so I want you to try B by yourself. And this is not a Pythagorean triple, so you'll leave it as a radical for the third side. Okay? So you could draw it over here, right? You could draw it. This is 5 and this is 6, so this is root 61. Yeah? Is everybody done? Okay, so sine theta is going to be 6 over root 61. So cosecant theta would be root 61 over 6. Cos theta would be negative 5 over root 61. So secant theta would be negative root 61 over 5. Tan theta would be negative 6/5. So cotangent theta would be negative 5/6. Everybody get that?